So hello everyone. Our project is signature forgery detection. Myself Satik Teja from fourth year CSE This project is done under the supervision of Balakrishna sir, CSE
Hello everyone, I'm T. Akshit Reddy from SR University, fourth year CSE. Our project introduction is basically in this project we are going to implement how to find a signature is original or fake. Firstly, we will train the system by using a database of signatures. This database of signatures is previously authorized by the system. This system will analyze all signatures and will make a reference signature will be used for other signature verification. There are many parameters in the feature space between the claimed signature and to be examined signature as a measure. If the absolute difference between the parameters of original signature and the verification signature is greater than a predefined threshold, then the signature is identified as forgery. Here we are going to use following libraries: TensorFlow, Math, Matplotlib, Pandas, Keras. TensorFlow and also our project problem identification is signature forgery detection refers to the task of determining the identity of an individual based on their signature. It's signature forgery detection, which focuses on determining whether a signature is forged or not. Signature detection, on the other hand, aims to match a signature to a known individual from a set of candidates, often in a multi-class signature classification setting. The goal of signature identification is to correctly identify the signer from a given set of known individual based on their signature. The system needs to learn the unique characteristics of each person's signature and differentiate between them.
Hello, I am Chandu from SR University, fourth year AIML. I am here to speak about the literature review of a project. Researchers have used many technologies such as neural networks, and they have done parallel processing to signature verification, and they are introducing concepts, new ideas, algorithms day by day. There are many other approaches which is evaluated of random forgeries like histograms, 2D transforms, measurements made on tracing of the signature, and thus the position of feature points located on the skeleton of the signature. This result indicates that this dynamics isn't stable enough to be used for signature verification, since the topic is trying to breed a shape instead of temporal pattern. Here we are going to verify only static images of signatures. And the objective of a project is SRVs, that is signature recognition and verification, is a system which is capable of addressing two individuals. The first one is identification of the signature owner, and the second is decision whether the signature is genuine or forgery. Here we see that signature verification are classified into two parts according to the actual needs of the problem at hand: A, online signature verification; B, offline signature verification. When a man is writing his signature, they give more information like hand speed and pressure management. And there are many things which we can take as key point to identify real or forged image. This project will help to solve the problem of forged signature.
Hello everyone, I'm Abhinav Reddy from SR University, fourth year AML CSE. Our proposed plan for this project is the signature verification system is started with the input of the user ID. The user is required to key in his or her ID to the system. The system will decide whether the ID is registered or not previously in our database. If the user ID is not registered, the user has to drop down 5 sets of signatures for training purpose. The signatures will be stored in the database. If the user ID is registered, the user will then be asked to sign for testing. Then the input training signatures and the input testing signature will proceed to the pre-processing stage. After this stage, the input training signature will be saved as reference signature in the database, while the input testing signature will be saved as sample signature and proceed to verification stage. In the verification stage, the sample signature will be compared with the reference signature which stored in the database. If the difference between two signature does not exceed the threshold value, the sample signature will be accepted as genuine signature and vice versa. And existing plan versus proposed plan. Existing plans for forgery detection include offline and online methods. Offline approaches analyzes static images using techniques like feature-based models like geometric texture and shape features, or deep learning models like convolutional neural networks, which is CNN, which automatically learn signature patterns. Online methods use dynamic data captured during the signing process. Example, pen pressure, speed, and leverage time series models such as recurrent neural network or long short-term memory networks. SRVS is a system which is capable of addressing two individual units. SRVS is nothing but signature recognition and verification. The first one is identification of the signature owner, and the second one is decision whether signature is genuine or forged. As we can see, this is the flowchart of our project. While the user puts his user ID, the user should be registering. If the user registers with yes, the signature will be going for testing. If the user registered for no, uh, it will also go for testing again. Uh, then it will be going for pre-processing. Uh, at the other hand, it will be saved as a sample where if the user clicked no, then it will be saved as a sample reference signature to the database. And at last, verification will be done. If signature is genuine, it will be called out as genuine signature. If it is forged, it will be called as forgery signature. Uh, Regarding the images, this is the pattern of the images. Some format of the signature image is in our model is XXX, ZZZ, and YYY.png. Triple X denotes ID of the person who has signed on the document. Triple Z denotes the ID of the person to whom the sign belongs in actual. Triple Y denotes the nth number of attempts. According to us, if triple X is equal to triple X, then image is genuine. Otherwise, the signature is forged or fake.
Hello, I am Kaushik Asugoni from SRU from fourth year CSC AML. The future scope is further developments may lie in more sophisticated machine and deep learning techniques such as convolutional neural networks or transformers. These can be capable enough to considerably boost the performance of forgery detectors. Models should be able to handle complex patterns, be adaptive to handwriting changes, and thus make the system applicable all over the world. Another area that is promising lies in extending the system to digital and electronic signatures. They are more and more frequently used in many online transactions and documents. Lightweight models will also be developed for running in mobile or IoT devices to support portable and on-the-go signature verification. Other dynamic features like pen pressure, velocity, and sequence of strokes from digital pens add another dimension of strength against intelligent forgeries. Furthermore, the system is scalable to become a part of large enterprise solutions and can be used in supporting the bulk verification of documents, hence increasing security in many industries. Result and discussion. This project will help to identify original and fake signatures. In the training phase, the training depends on the size, amount, and type of data. The size of our test set is relatively smaller than that of general machine learning datasets. As a signature is generated by human action, mistakes occur frequently, even though the signature is drawn by the same person. In the test phase, a mistake may result in single verification failure. However, in the training phase, a mistake could lead to decrease in verification accuracy.
So, I will. Hello, I'm Satvik Teja from SR University, studying in fourth year CSCAML. So, the code of the project signature forgery detection runs like this. These are the libraries: NumPy, TensorFlow, Matplotlib, and Skippy, skimage. These are used for numerical computations, deep learning, image processing. And here are the parts of the real images and forged images which are took in the sample data in the left side. And here RGB gray, this feature is used for converting an RGB image into grayscale by averaging the pixel values. And here the grayscale image is converted into binary image for the understanding of the system. And here the image is pre-processed to extract the region containing the signature. So these are the data sets and parameters of the project: centroid, sensitivity, solidity, skew, kurtosis. Here this process combines all the pre-processing and feature extraction functions to generate a set of features for an image. It creates this process creates training and testing data sets. Here the training and testing datasets by extracting features are created for both genuine and forgery signature, uh, and they are saved as CSV files. This is the testing of the signature. So here the main code runs. Here the evaluation functions are used like evaluation, train phase, and test phase. This is the training data, and this is for the testing data. It predicts whether a single test image is genuine or forged. It runs the evaluation pipeline for multiple people. So here the ID of the person is given, and the path of the signature image is taken. Here we take the path of random image. And it shows whether the image is forged image or not.